The Altoids Arduino temperature sensing project. The circuitry for this project is the same as the last one, and so is the function of the circuit. However, this circuit is soldered to a permanent protoboard and is placed inside of an Altoids tin, keeping it compact and durable. Just like the previous project, it is powered by a 9-volt battery regulated to 5 volts, with a cutout for the DC jack on this side of the tin. At the top, the PCB for flashing programs via an AVR programmer is available. The bar graph also has a cutout to allow the temperature reading to be viewed. On the side of the tin, the thermistor sticks out, allowing for the temperature to be read away from the other components on the top, keeping them safe from extreme temperatures. The processing function of the circuit is powered by the ATmega 328P, housed safely beneath the lid. Finally, the on and off buttons are available at the top of the circuit. The entire circuit is built upon a permanent protoboard like this one. It has through holes and gold pads, allowing components pins to be soldered onto the board conveniently. The holes on the numbered rails in the middle are connected in rows of 5, like on a regular breadboard. The outer holes, however, are individual, allowing for a lot of components to be placed in a very tight space. New programs can be flashed without the need for the removal of the tin's lid via the 6-pin male port on the PCB, which can be connected to an AVR programmer. To keep components from having to be directly soldered to the board, exposing them to dangerously high temperatures, chip seats and headers are used. They are soldered to the board alone, and then the components' pins are stuck inside of the female ports, allowing for them to be removed at any time. As the metal of the tin is conductive, care was taken to ensure no shorts were possible by lining the lid and some of the interior with electrical tape.